Okay, so this week our main focus will be factoring. And before we delve into how to do factoring, we'll first examine what factoring is. So the definition of factoring is when we express a series of sums as a series of products. So what do I mean by this? Well, last time we saw that we have x plus y squared is equal to x squared plus 2xy plus y squared. So in the left, we have a series of products because x plus y squared is the same as x plus y times x plus y, right? That's a product. However, on the right, we have a series of sums because we can see that these are adding to each other. So this is a sum. So when we go from the left to right, we talked about it last time. This is called expanding or simplifying a polynomial. Now, opposite to this, we have factoring. Factoring is when we go from the right to left. So we can see that in factoring, we have a series of sums. And then after we factor it, we have products. Okay. There will be two main ways for factoring. David, do you want to start with it?
Yeah, okay, so we're gonna go with like the simplest one first, which is called factoring by grouping. So this method is quite useful if you have a polynomial that has 4 terms or more. And like every factoring technique we're going to talk about today, you're going to use this factoring technique after you've taken out the GCF of a polynomial, which should always be your first step when you're factoring. So you should use this method. Again, when I said you have 4 terms or more, and there isn't really a GCF that you can take out anymore. So for example, we could have the polynomial x squared plus x plus 1 plus x cubed. Yeah, plus x.
X squared plus x cubed.
Oh, no, plus 1 plus x cubed.
Oh.
Yeah, it's fine.
But yeah, it's fine. The order doesn't matter.
Yeah. So remember our first step. So we can see if there's a GCF, and we see that there isn't a GCF we can take out. So our next step should be to arrange the polynomial in descending degree. So remember that from last class where we sought the degree of the polynomial. So x cubed plus x squared plus x plus 1. So that there's a polynomial with descending degree. And what we know is that we group 2 terms together. So in this polynomial, we don't really have to like strategically group them, but it's recommended. We can technically just randomly group terms together. But in this case, we're just going to group the first 2 terms and the last 2 terms together. And by grouping, I simply just mean putting the terms in brackets. So you put the brackets and then x cubed plus x squared, and then you do that with the other 2 terms. And now we technically group the terms together. And now what we do is that we treat each group as a separate binomial, which we can take the GCF out of. So we look at the x cubed plus x squared individually first. We can see that in that first group, there is a GCF of x squared, which we can take out. So we take it out and then find what is in the brackets. And then we do the same with the other group as well. But in this case, we see that there really isn't a GCF. But just to make this more visually simple, we're just going to take out 1, even though it's not a GCF. It just makes it kind of simpler to see. And now we see that we actually have 2 kind of like terms. We can think of the x plus 1s as a variable. So we can define a new variable like y, which is equal to x plus 1.
I think we can just do it like directly because that just makes everything more confusing.
Okay, yeah, we're gonna do another method. So here we see that we kind of manually created a GCF, 2 terms, which has a GCF. So what we can do is that we could take out the x plus 1. So we do x plus 1, and then what we do is that we took it out, and now what we have left is x squared plus 1 multiplied with the x plus 1. And that would be how we factor with the grouping. And we should do another example.
Yep. All right. I have a good example.
Okay.
Sorry, let me just quickly pull it up. Okay. So 3x squared plus 6x plus 4x plus 8. Now, our first step is to take out any GCF, but we see we don't have a GCF. So then our next step is to arrange it in decreasing order. But then we see that it's already arranging decreasing order. So then we can just start grouping. We'll just randomly choose the first two to group, and then the last two terms to group. In our first two terms, we see that the GCF is 3x. So it's 3x times x plus 2. On our right hand side, we have the GCF 4 times x plus 2. So then we see again that we have a common GCF, a common factor, I should say. Now these two are like terms, so we can add them together, and we get 3x plus 4 times x plus 2. So the coefficients of these go here, and then this factor goes here. All right, we can do one more example.
Yes.
David, do you have a example?
Yeah, I can try to find one.
All right. I have another one. So
wait, I just found one as well.
Oh, okay.
Okay. Okay. Shall we do mine or yours?
We can do yours.
Okay. So we have 2x squared plus y plus x plus 2xy. So we can do grouping again. Let's just choose the first two terms and the last two terms again. And we can kind of see that there is a little bit of problem when we create that group, because in the first group we have 2x squared plus y, which we can't take anything out of. And then the last group we can only take out x, and that only leaves us with 1 plus 2y. So we see that this group isn't good, so we just choose another group. So maybe we can alternate it a little bit. We can group 2x squared with x, and then 2xy with y. And here we can write it out. We have 2x squared plus x
In brackets.
plus 2xy, y plus 2xy. The order doesn't really matter, but whatever. And then we can take out the GCF of each. So in the first one, we have x times 2x plus 1. And the second one, we have y times 1 plus 2x.
Yeah, and then we can just flip it. So
yeah,
like terms.
Yeah, associative property of addition. And then like terms, take it out. And we have x plus y times 2x plus 1.
Okay. So now we're going to give some examples for you guys to try. Try this example. 6n to the cube plus 3n squared plus 8n plus 4. When you're done, you can just type your answer into the chat.
Kevin, wait, do you have the right answer, Kevin?
Yes.
Okay. Because we
Uh,
have two opposing answers in chat, and
okay,
I'm
the
not
thing
sure
is,
which one's right.
both of them are the same. Wait.
One of them is different.
Oh yeah, one of them is different. So the correct answer is actually Roy's. Edward, you're really, really close. But the problem with yours is you forgot to take out the n from the first factor. Yeah. Could take out an yeah. You can take out an extra n. Yeah, that's right. Okay, so we can start doing this. We'll just group the first two and the last two, because usually in a descending power, this is how it goes. So 6n cubed plus 3n squared plus 8n plus 4. The GCF of the first expression is 3n squared. So 3n squared times 2n plus 1. The GCF of the second one is 4. So 4 times 2n plus 1. We have two like terms. So we can combine their coefficients to get 3n squared plus 4 times 2n plus 1. So that's our right answer. Should we do another example for them to try?
Yeah, I think we should.
All right. Do you have something in mind?
Hmm. Okay,
I
wait, I
can
don't
give
have an
it.
example. Yeah, you should give one.
All right. Uh, okay. I'll try to think of a hard one. Okay. X cubed minus 2x squared plus 5x minus 10. If you guys are done, you can type in the chat.
Uh,
Huh. Let's see. Not 10, 2.
oh yeah, Edward, I think you forgot to divide the 10.
Yeah, the purpose of this is to combine factors. It's fine. Wait, Roy texted x minus 2 times x squared plus 5. Yeah, good job. That's the right answer. David, do you want to explain it or should I just go for it?
I can explain it.
All right. Okay.
Okay, so in this case, we can just do the always default, which is combine the first two and the last two terms. So you have x cubed minus 2x squared plus 5x minus 10. And then in the first one, we see that there's a GCF of x squared, so we can take that out. Gives us x minus 2. And in the second one, we can see that there's a GCF of 5. And then we see that we have x minus 2, which is common, so we can take that out as well. And we end up with x squared plus 5 times x minus 2.
I think that's plenty of examples. Do you guys all understand how it works?
I'm going to assume that's a yes.
All right, let's take silence as a yes.
Yes. Okay. Should we move on to the next method?
Yeah, so since there are only two methods in this lesson, we'll just give a lot of examples for each of them.
Yeah. Okay, so the next method we're going to talk about is decomposition. So this is useful for polynomials which have a degree 2. And when we have a polynomial which is degree 2, we call them quadratics. Fancy term. Yeah, so there's going to be two type of quadratics that we're going to deal with. So what we're going to deal with now is in the form of x squared plus bx plus c, and where the x are non-zero integers, so whole numbers. So an example of this will be x squared plus 3x plus 2. And it doesn't always have to be addition. We can also do x squared minus 5x minus 14. Okay, so how we factor this is, remember in the previous lesson, we kind of talked about how when we have a trinomial, we always end up with two binomials multiplied together. So for example, x squared plus bx plus c, we can, okay, wait. Yeah, that's not a
We
great
can
way
give
of
a
putting it.
concrete example. So like x
Yeah,
plus 5 times x plus 2 or something.
yeah, 2, I
So,
guess.
right.
Yep. And then what
So
we can do
when
is
we
that,
expand, oh, sorry.
oh, no, you can go.
Okay, sorry.
Yeah.
So when we expand this, we'll just skip the FOIL method since I'm sure you guys all know it by now. Plus 7x plus 14. So on the left, just as a quick reminder, on the left we have the factored form.
Kevin,
Yeah.
is it
Oh,
14?
whoops. Sorry.
I think it's 10.
Yeah. Sorry.
Yeah.
My bad. Yeah. So the left is called the factored form, while the right one is called the expanded form. Okay. So in essence, when we try to factor something, we go from the right to left. So there's something that we can notice here. So the middle number is actually the sum of these two numbers, 5 and 2. 7 is actually 5 plus 2. This 10 is actually 5 times 2. Is this a coincidence? No, it's not. We can actually prove this
Yes.
by
We can use variables.
variables.
Ecthic. Okay. X plus.
All right. So we see that the middle number, the coefficient of x, is a plus b, and the constant is a times b. So that means when we try to go backwards, if we're given what this is and what this is, then when we try to go backwards, we try to find two numbers that sum up to the middle number and two numbers that multiply to get the constant. All right, David, you can do the next one.
Should we give an example?
Yeah,
Like
so we're
using
just
this? Okay.
elaborating. Yeah.
Yeah, so if we have a quadratic x squared plus 3x plus 2, to factor this, we can use the thing we just talked about. So there must be two numbers a, b that add up to 3 and multiply to 2. So a simple way of doing this is just that we're going to list the factors of the constant. So in this case, the constant is 2, so its only factors are 1 and 2.
Plus minus 1, plus minus 2.
Oh yeah, that's true. But we're not there yet, so.
Yeah.
Yeah.
Okay.
So in this case, we kind of realize that positive 1 times positive 2 gives us 2 because obviously that's the factors. But also positive 1 plus positive 2 gives us 3. So our a and b's are 1 and 2. Yeah, it doesn't really matter for now. Yeah, we can have x plus 1 and times x plus 2. and that will be the factor form.
All right, another example. X squared plus 6x plus 9. David, you can do this if you want.
Okay. So here we see that there must be a number that add up to 6 and multiply to 9. So what we can do is that we could just list out the factors of 9, which is 1 and 9, and then 3 and 3. 1, 3, 9.
Yeah. Okay.
Yeah. And then here we could just try out the combinations. We can see that 1 plus 3 doesn't work. Wait.
1 plus 9 doesn't
Yeah,
work.
1 plus 9 doesn't
does.
work. 3 plus 3 does. And yes. A is 3, B is 3, and we have x plus 3 squared.
Should we do like one more?
Should we do a -1? Should we?
Oh yeah, sure. We can just use the previous example.
Oh yeah, that.
X squared minus 5x minus 14. Oh, someone already typed in the chat the answer. All right, yeah, you're correct. Good job. We'll just explain the thought process.
Yep. Okay, so we see that we have a negative sign, so there must be two numbers that add up to -5 and multiply to -14. And we kind of list out the factors of 14. So we have plus or minus 1, plus or minus 2, plus or minus 7, and plus or minus 14. And here we can see that to end up with a negative when multiplied together, one of the numbers must be negative. So we can try out combinations. We can see that there's no way for plus or minus 1 and plus or minus 2 to end up with it. But we can see that if we have -7 and +2, we can have this exact combination. And then we can do x minus 7 and x plus 2, and that'll be your factored form.
Oh yeah, a equals 2 and b equals -7 works as well. The answer will just be x plus 2 and x minus 7, and these two are essentially the same thing. So if the coefficient of x squared is 1, then it doesn't matter what a and b is. Oh, scroll up a little bit? Yeah, sure. All right, awesome. Do you want to do one more, or should we just give them some?
Just give them some.
All right, sure.
Yeah, okay. Oh wait, we should do like only one negative sign. Should we do that? Or like, I feel like that's the same kind of.
One negative sign? Oh yeah, sure.
You have like x squared minus 3x plus 2. Okay, here we have one negative sign, so it must add to -3 and multiply to 2. And multiply to 2. And here we see that the only way for two numbers to multiply to be a positive is that the two numbers must be negative. So we can list out the factors of 2 again. So we have plus or minus 1 and plus or minus 2. And since there are only two factors and both of the a and b must be negative, it must be -1 and -2. And we can have x minus 1 times x minus 2, and that will be our factored form.
Okay. Some examples for you guys to try out. Let's do 2x squared plus 4x minus 16. The hint is to first extract the GCF. When you're done, you can just type your answer into the chat. 2x plus 8 times x minus 2. Yeah, that's correct, but you can extract the GCF. Yeah, make that x plus 4, and yeah, that's correct. Good job. So first we extracted GCF, which is 2, and then we get x squared plus 2x minus 8. Then we have x plus 2 equal to 2, and a times b is equal to negative 8. The two numbers are a equals to 4 and b equal to negative 2. So we have 2 times x plus 4 times x minus 2. David, do you have another one?
Yeah, we can do x squared minus 9x minus 10.
Yep.
Yep.
Yeah, good job, Roy.
Okay, so let's just go through this one. So a plus b must equal to negative 9, and a times b must equal to negative 10. And in this case, the only answers are, should we list out the factors again or no? Just go straight
It's
to the answer.
unnecessary.
Okay, well, we have a equals to 1 and b equals to negative 10. And we have x plus 1 and x minus 10.
Okay, one more, or should we go on?
What do you feel like?
We can just go on, I think.
Okay.
Yeah. All right.
So,
Okay. So David mentioned that the first case is when the coefficient of x is 1, strictly 1. But what if the coefficient of x squared is not 1? Let's say 2 or 3. So in this case, it would be ax squared plus bx plus c, where a is not necessarily 1. It could be other integers. So do you want to explain how to do this one?
yeah, sure. Okay. So it's kind of the same as if the leading coefficient is 1, except we make one change, which is that we must find two numbers which multiply to a times c and add up to b.
So let's just call the...
Yeah.
Okay, this is a little confusing, so we'll just give an example. So 2x squared plus 3x... it doesn't have to be factorable. Okay, so because it was confusing because if we named our roots a and b, then like
Oh yeah.
the
That's kind of
coefficients are
confusing.
a and b too. So two numbers, a, b, that multiplies to c, add up to b. So the same as our previous method.
Should we
And
just call
then,
them xy instead? Wait, no, there's already x in there.
oh yeah. Okay, wait.
It's getting kind of confusing.
It is, yeah.
Yeah. M and n, how about that?
M and n, sure.
Yeah. So we have two numbers m and n, which is what we are trying to find.
Yeah. Okay. So we can just write out the two factors. I think that'll be easier.
Yeah.
Oops. Okay, so these are our two factors, but they're empty right now. We're trying to find what it is. The first thing is that we see that the first two numbers of each factor that includes the x term has to multiply into 2x squared. So for example, it could be 2x times x, or it could be x times 2x. So the first thing we see is that these two numbers must multiply to 2x squared, and then we will name the constant of each factor a and b. In this case, when we use the FOIL method, we see that 2ax plus bx is equal to our middle term. And then a times b is equal to our last term, so 1. So what this gives you is 2a plus b is equal to 3, and a times b is 1. So there isn't really a rule like the last one. In cases where a is not 1, you just have to like try out different combinations of the first two x terms. I think we should do an example.
Yeah, we should.
Yeah. Okay. So let's do 6x squared plus 13x plus 6. Now, the first two x terms can either be 1x times 6x, or it could be 2x times 3x. And then we can just do a and b plus a and b. In our first case, we see that 6a plus 1b is equal to 13, and a times b is 6. So, okay. So then a is equal to, let's see. Is that even factorable? Yeah, okay. So since this case is not factorable, we can't have integer solutions. We move on to our next case. In our next case, we see that 3a plus 2b equals 13, and then a times b is equal to 6. Now in this case, there is a solution, and the solution is a is equal to 3 and b is equal to 6 at 2. So then we just use the second form, and we do 2x plus 3 times 3x plus 2. Yeah, so when the coefficient of x squared is not 1, it's much more confusing and much more harder to do. Do you want to do another example?
Yeah, we should.
All right.
Do you want to do...
Oh, sorry.
Oh, okay, yeah, let's do your example.
Are you just doing the 4x squared one? This one?
No, I was looking at another one, but I think that one's pretty good.
Oh, okay. All right. Do you know how to like do this way, or should I explain it?
Using your method, I've never seen that way before, so...
What's the other method? Kind of.
Oh, you multiply the leading coefficient with the constant, and then you just brute force through all the possible factors and do like the a times b and then a plus b thing.
Oh, well,
Yeah.
that's okay. We can try that.
Yeah, but like the numbers get very big very quick.
Yeah. So I think honestly we should just like do my method for bigger numbers,
Yeah.
and then we could try David's method later. So in this case, we have either 4x times x plus a plus b, or we have 2x plus a times 2x plus b. In this case, we have 4b, a plus 4b is equal to 16, and a times b is 15. Are there any solutions? I don't think so. So there are no solutions to this form. In our next form, we have 2a plus 2b is equal to 16, and a times b is 15. So a plus b is 8, a times b is 15. Now in this case, a is equal to 3 and b is equal to 5. So there is a solution, and the solution is 2x plus 3 times 2x plus 5. All right, David, now we can do your method.
Okay, yes. So we can use 4x squared plus 16x plus 15.
Isn't that the
So
same? Wait, okay.
wait, oh my gosh, it is. Okay. Well, we can also do it, whatever.
Oh, yeah,
So
sure.
what we do is that we multiply the leading coefficient with a constant. So we end up with 4 times 15, which is 60. And then now what we gotta do is that we gotta find two numbers which multiply to 60, but also add up to 16. So, oh, wait, something's wrong. A plus B for the second one, Kevin.
Oh, sorry. Oops. Okay, I can see how this gets very large.
Yeah. And now we gotta find all the things. Oh my gosh. Okay. Yeah, wait. Okay, it's just A is 6 and B is equal to 10 because 6 times 10 is 60 and then 10 plus 6 is 16. And now what we got to do, this is a real fun part, okay? We got to somehow get the leading coefficient in there. So these numbers, one or both of these numbers are multiplied by the leading coefficient. So you got to try all the possibilities with 4x and x and 2x and 2x.
Oh,
Yeah,
interesting.
so yeah, 4x and then plus something and then x. And then we have 2x and another 2x. And what we see is that we just try to fit both of them in there. So, okay, I don't know how to explain this method.
Yeah,
It's
it's
just kind of brute forcey, yeah.
4x plus 10 or x plus 6. 2x plus
Yeah, wait, okay.
6.
It's hard to explain.
It is, yeah.
What we do is that we kind of divide by the leading coefficient,
Wait.
kind of. Wait, divide
Oh,
by okay, it's hard to explain, but for example, in the second one, what we're trying to do is that we're trying to see if the coefficient 2 in front of the x multiplied by something gives you 6 or a 10.
I see how your method works now.
Yeah.
Okay, so we have A is equal to 6 and B is equal to 10. So then we divide 6 by 2 to get 3, and then 10 by 2 to get 5. Is that kind of right?
Yeah, that's right. And then you see
Okay.
if it's an integer or not. And if it's not, you probably got it wrong.
Yeah. Okay.
Yeah.
Oh, I see. 6
This
divided by
is
4. And
yeah.
then 10 divided by 1, which is 10. Okay.
Yeah. It's not the greatest method, but for like small quadratics, it works fine. I don't know why my teacher didn't teach Kevin's method, but oh well.
Oh, my teacher taught me this method. It works for me, so.
Uh, oh, okay.
Okay. Yeah, so choose whatever method you prefer. Honestly, like I'd probably go with my method because it's like you don't have to try out a bunch of things. There's only like a formula that you have to apply.
I gotta agree with you on that, but this method is kind of stuck in my head now, so oh boy.
All right. Okay.
Yeah, we should do more examples.
Yeah.
Oh wait. Should we try like a oh yeah, let's try yours first.
Okay. One more example, and then we'll give some for you guys to try. So in this case, it's either 6x times 1x or 3x times 2x. I don't know why I made my brackets so big. So we have plus a plus b plus a plus b. In this case, in our first form, we have a plus 6b is equal to negative 21 and ab is equal to 9. Are there any possible solutions? I don't think
Yes.
there
Wait,
is.
no. Yeah, no.
No, okay,
Wait,
yeah.
wait. What if you have -3 and -3?
Oh yeah, okay, that works. Thanks. So a is -3 and b is -3. Yeah. Oh, smart. So then we can just substitute a and b in 6x minus 3 times x minus 3. And then, okay, sorry, I kind of skipped a step, but we first needed to extract the GCF. But we can do it right here as well. So 3 times 2x minus 1 times x minus 3.
Yeah, always remember extracting GCF, because if we extracted GCF on our first step, I think it would have been easier.
Yeah, definitely. Okay, so now we'll give some examples for you guys to try. Let's do 6x squared minus 13x minus 15. Uh, 6x plus 5 and x minus 3. Let's see. Yeah, that's correct. Good job, Roy. So David, do you kind of like understand my method, or should I explain it?
Yeah, I kind of do.
Okay. Do you want to explain it then?
Yeah, I'll explain it. So what we do is that we kind of write out all the possibilities for making 6x squared, so 6x and x. And then we also have 2x and 3x. Oh yeah, okay, it's fine if you write it that way
2x?
also.
It's okay. 3x.
And then I think you have 6a plus b, or is it 6b plus a?
It's okay. So this is one. So what we do in this step is
Oh wait,
we
yeah,
use the
it's a
FOIL
plus
method.
6b.
Yeah.
I see. Yeah, 6b plus a. So 6b plus a must equal negative 13. And a times b must equal negative, is that 15? Oh yeah, it is. Okay. Uh, wait. Oh yeah, I think it's
Yeah. A is
negative
5.
3. Oh,
Oh, wait.
did it wrong. Whoops, you're
That's
correct.
okay. B is negative 3. I just look at the answer and like just
Uh,
substituted it. So 6 times 5 is 15 plus, wait, hold up. Okay, sorry. 6 times negative 3 is negative 18 plus 5 is negative 13. And 5 times negative 3 is negative 15. So that's correct. And now we just substitute it in. Plus 5 x minus 3. So sometimes like both of these gives you integer solutions, but I mean on a test, if you're asked to factor it, you just need one, right? Like why would you do both if you only need one? Okay, should we do
should
like,
we do
yes.
this really hard one?
Is it like the 20x card one?
No, the 45x squared.
Oh, that one we did in class. It took us
Oh, we
like
did?
20 minutes in our class, yeah.
Oh,
First person got
okay.
it in like 20 minutes. Nah.
Okay. Yeah, let's do the 20x squared one.
20,
Wait,
yeah.
that one's
Even
still a
that is
stretch.
pretty. Yeah, we should just do the 8x squared one.
Yeah.
Okay. Oh,
Yeah,
oops.
with big numbers, you definitely do not want to use my method.
Yeah.
45 times negative 63. Oh boy.
Every time we do like one of these questions, it always takes up like half the class.
Yeah, put your
It's
answer
hard.
in the chat.
Yeah.
And remember the first step for factoring any polynomial or quadratic.
Take out GCF. Oh, someone already texted. I can still see a GCF in 2x plus 4. But yeah, otherwise, that's correct. Good job. Yeah, there we go. Nice job. We'll just wait a couple more seconds. I'll give you 2 more minutes. Okay, I'm assuming you guys all have tried it out. So now we'll work it as a... So now we'll find the solution. It's either 8x times 1x or it's 2x times 4x. In our first case, we have 8b plus 1a. A plus 8b is equal to 26. Oh, okay, sorry. I forgot to factor out the GCF again. Take out GCF. The GCF is 2, so we have 2 times 4x squared plus 13x plus 10. So it's either 4x times 1x or it's 2x times 2x. In our first case, we have 4b plus a plus 4b. Always have the a first, so it's easier. And then we have a times b is 10. Let's see if there are any solutions. Okay, so one solution is a is equal to 2. Wait,
I think B is equal to 2.
oh yeah,
I think
b
that
is equal to
works.
2. A is 5 and b is 2. So then we have 4x plus 5 times x plus 2. Yeah, that works. And then we can't forget about the 2. All right, that's all for this class. We do want to go through a couple examples in our worksheets. All right, which problems seems interesting?
Oh my gosh. It's
Too many.
easy. Okay. Should we do the first one? What's the first question?
No, it's not really. I think we should just do the simpler ones.
Okay. Let's do number K.
Okay. Oh yeah, sure. All right, are we good to go? Two x plus 3 times x plus 5.
Yeah, that's right.
Oh yeah, that's right. Good
Yes.
job. So, I mean, in this case, we only have one possible form, which is 2x and x. So then we do plus a plus b. A plus 2b is 13, and a times b is 15. A is equal to 5. I mean, 3, and b is equal to 5. So then when we substitute these in, we get 2x plus 3 and x plus 5.
Hey, you can do this one with my method if you really wanted to.
Yeah, sure. We can do it with your method as well.
I don't think it'll be simpler, but oh well.
We can try it. I mean,
Yeah. Here, a plus b is equal to 13, and then a times b is equal to 2 times 15, which is 30. And here we can see that a is equal to 3 and b is equal to 10. And then we can also see that there's only one possibility, and that 10 is divisible by 2. So we do 2x plus 3 and x plus 5.
yeah.
We just
So
plus 3 and then plus 10 divided by 2, which is just 5.
times x plus 5.
Yeah, plus 5, because 10 divided by 2. It's kind of confusing, but
Wait, but isn't it 10 divided by this? What's going on?
no, because wait. Because when you add a and b to get the middle coefficient, you technically do 2x times the last times the 5 to get 10x.
Oh,
Kind of hard to
really?
explain, but yeah.
Huh. Okay. Oh, I see. So I don't know if it's just me but like I feel like this method is just like more work for no reason.
I agree, which is why I was so surprised when I learned of your method.
Yeah, because you go through multiple steps without like accomplishing anything. So 10, yeah, so 2x times 5 is 10. Okay, yeah, that makes sense. I mean, it works. 25 parts for question 1. Yes,
Yes.
there's a lot of parts. Oh wait, no, there's more.
There's all the way to ZZ. Okay.
Yeah, there's more. 52 parts. Yes, bruh. Yeah, factoring, but for factoring, you just have to do a lot of practice. Like it's not very intuitive at first. You got to do a lot of practice.
Yeah, and also if you're doing factoring, you're not really going to encounter a lot of variety. It's just mostly going to be these type of questions.
Yeah, just a lot of questions. Edward, do you not get my method or David's method?
Here, yeah, if you don't get my method, don't worry about it. You don't need to know it.
Wait, do you high school teachers teach my method or your method?
I don't know. Milner taught me this method, so.
Oh. Huh. Okay, we can do another example.
Yeah, Edward, don't worry. If you don't get it, you don't have to.
Yeah. Which one do you want?
Oh, we can do a negative coefficient, like negative leading coefficient W.
Oh,
Wait, is
W?
that two V's or a W?
I think it's
that's
two V's.
Yeah.
Yes, that's correct. Good job. But we usually don't have negative W in our factors. So just extract the negative one out.
Yeah, just divide by -1.
Yeah.
Perfect.
Yeah, perfect. Nice. So this is equal to negative m squared minus 3m minus 4. A plus b is negative 3. A times b is negative 4. So a is negative 4 and b is plus 1. So we get negative a minus 4, or in this case, m minus 4 times m plus 1. That's our answer. Good job.